Hi, welcome to this lesson on Euclidean geometry, circle theorems, the center and chord theorems. Let's have a look at question 6. So in the circle with center O, we have that OQ is perpendicular to the chord PR, and that the length of the chord PR is 8 units. We're also given the length of this little line QS here, of that long center line there, from O to Q, is given as 1 unit. Okay. We want to determine the value of x, in this case is the radius line OP. So let's write everything we've been given in terms of this problem. First of all, a circle with center O. Again, always very important if we know the center of the circle, because it enables us to use any theorems that have the center as the key point. We also have from the center a perpendicular line OQ to the chord PR. We're given the length of the chord PR is 8 units, and the length of the little part of OQ, which is SQ here, is 1 unit. The goal is to determine the value of x, which in this case is the length OP, which is a radius line. So now, let's fill in that information. So this line OQ is perpendicular from the center to a chord. So my proof is going to start off as follows. I'm going to claim that PS equals SR, and that's because the line OQ is a perpendicular line to PR, so that perpendicular line bisects, so perpendicular line from center bisects the chord, because we know that O is the center. So we can therefore use this theorem. So it bisects the chord. So furthermore, if I let these lengths be Y, I therefore have that y plus y must be the total length PR, so that means 2y must equal 8, because the chord length PR was 8 units. So therefore, the length of one of them is 4. So that is 4 and that is 4. Bisects the chord in half. Okay, so what else am I looking for? I'm looking for this radius length here, but I can't quite solve it just yet. So what I'm going to do is I'm going to pull out that triangle and notice that it's a right angle triangle at the points S, O, and P. So PO or OP here is x, that is the hypotenuse length of this right angle triangle. I know the length of SP, we worked it out now, that is 4 units. But what about the length of OS? Now, we haven't used SQ equals 1. We've used the circle with center O, we've used the perpendicular line, we've used PR equals 8. So we need to do something with this information to fully solve the problem. But now I notice that OS, this length of the line here, is attached to this longer length OQ. But OQ is equal to OP, which is equal to x, because these are radii lines. So if the full length of this thing is x, and the smaller length is 1, then the length of OS, so OS, must be the full length OQ minus that length QS, which is equal to x minus 1. So now we have the length of OS in terms of x. Lastly, we can use the theorem of Pythagoras here. So by Pythag, what do we have? We have that 4 squared plus x minus 1 all squared equals x squared. So now we've reduced all this to a simple algebraic equation, which we can now solve for x. So 4 squared is 16. Now to expand this out, you are doing x minus 1 times x minus 1. And if we distribute that out, we'll get plus x squared minus 2x plus 1 equals x squared. Now I can subtract x squared from both sides, and therefore get 16 minus 2x plus 1 equals 0. So 16 plus 1, those are like terms. So I have 17 minus 2x equals 0. I can therefore add 2x to both sides, and I get 17 equals 2x. And then lastly, divide both sides by 2 to get x equals 17 divided by 2, which is 8.5. Okay? So therefore, the full solution here, okay, so just check that there, 8.5. The full solution here is that we've used every single piece of information that was given to us. We have the correct theorem reasonings for our claims, and therefore we're able to take out the right angle triangle and use the theorem of Pythagoras here. So the key when doing circle geometry problems is 1, make sure you write down every single piece of given information. The second step is look for any theorems that can be applied to the given information. From that step, see if there are any unknown values you can find on any of the lines. The next step is, are there any right angle triangles? Because if there are, then we can somehow use Pythagoras there somewhere and therefore solve for any unknown lengths. Okay, so that's how we would do this type of problem. I'll see you in the next one.